Hello everyone, welcome to the advanced ML session of Snowpark Container Services. I'm Imam, I'm the product manager for Snowpark Container Services. There's a lot of excitement around it. This is one of the most advanced sessions for Snowpark Container Services where I have the honor to have Kelly with me from SailPoint, who's already pushing the limits of Snowpark Container Services. Kelly, you want to introduce yourself?
Yeah, thanks, Mez. So I'm Kelly Grizzle. I'm a distinguished engineer at SailPoint, and I work on our data intelligence team, which does all of the AI and ML and data platform work for SailPoint. For the astute watchers, I'm wearing the same shirt that I have in my picture here. That's because SailPoint usually keeps me locked in a cave behind my computer. I do not wear button-ups. It's like shorts and flip-flops usually, so this is as good as it gets. You're welcome. All right, so today we got a lot of stuff to cover. It's going to be a fire hose of material. Muzz is going to do a brief intro on Snowpark Container Services, which you may have already heard about. It's announced this week. And then I'm going to tell you a little bit about SailPoint, what we do, just so I can set the context of the use case that we're trying to solve. We'll talk about identity security. We'll talk about celebrities. And what kind of session is a session without a demo, right? So this is an advanced session. We'll be going into a demo and then talk about kind of next steps and what you can use.
Awesome. Thank you, Kelly. So we have a lot to cover today, and there's a lot of exciting stuff. So I'm going to level set and get out of the way so Kelly can show us the magic he's been doing with Snowpark Container Services. So just to give you a context so you understand what is happening through the session, and we are going to focus a lot on this right bottom box today, but I wanted you to understand the concept. So you know Snowpark is our platform for doing data science, data engineering, all those advanced workloads in non-SQL language. We have client libraries, and we yesterday announced this feature store, how to do feature engineering through ML modeling API and then ML operations API. All of that runs on the warehouse side of things, on the server. But now we have a very powerful extension of Snowpark, which runs outside of the warehouse, which also supports GPUs, and that is what Snowpark Container Services is. And we're going to continue to expand our ML strategy. We'll have first-party more and more products coming that will be using both the warehouse and Snowpark Container Services. We already have vector search, for example, and semantic search running on Snowpark Container Services. We'll have third-party solutions using both warehouse and Snowpark Container Services. And then, most importantly, if you want to bring your own solutions like Kelly and SailPoint has done, you can get it started through Snowpark Container Services, bringing your own code. So let's quickly level set, and we have a very detailed session, what's new, Snowpark Container Services. The recording will be available. If you haven't watched it, definitely watch it. But just to quickly give you an intro, Snowpark Container Services is our managed container platform built for data cloud. Now what does it mean? It means that now you can start bringing containers and run them inside of Snowflake, inside the security of your account, right next to your data. So think of like running those C++ workloads, all those things that you were not able to run before, you should be able to run on the Kubernetes cluster right here in your account securely. And not only that, you're going to see later, Kelly is going to use GPUs, right? Very powerful GPUs. So we are not just giving you the option to bring the images and the containers of your choice, but also we're letting you choose the hardware you want. And right now, getting GPUs because of this LLM and generative AI is really hard, so we procure it for you. So you don't have to wait in line and get those hardware. It's just like warehouse, whatever you need, you create a compute pool and you just get it. Now the hardest part in getting all of this was basically trying to figure out how to take the complexity away from from a container platform and give you this ease of use experience that you are used to Snowflake. And Kelly is going to show us how quickly he was able to get everything running. And the second thing is, we want to tightly integrate with Snowflake data. So your data doesn't have to leave outside. You don't have to worry about the risk, governance, and the latency. And again, Kelly's going to show us that. And of course, you can start now packaging it up and start, distributing it as native apps and also consuming native apps as well. So with that, I won't take more time. Let's get to the most exciting stuff. Kelly, over to you.
Thanks, Buzz. Okay, my lawyers made me add this. You're warned. Okay, done. Okay, so who is SailPoint? I'm gonna tell you a little bit about what SailPoint does. You may or may not have heard of us. Just to set the context for the use case that we're looking at, right? SailPoint is an identity security company. And what does that mean? Imagine yourself starting at a new job as a data engineer, right? You need an email account. You need certain roles on Snowflake to be able to access the database. You've got to get into GitHub to check out code and check in code, Jira for ticket management, Slack, all that sort of stuff, right? SailPoint helps to give you the access that you need on all the systems that you connect to, and just the right size amount of access. Because with security, it's important that you have just enough and not too much, because that's when identity breaches can happen, security breaches. So why is this hard? Like, why do companies care about this? It's a really hard problem. You guys see this, you work remotely, all sorts of devices. Bringing new applications in and tools that you use is so easy with SaaS. You bust out your credit card, you've got a new app, right? You might have some sensitive data in there. It needs to be managed. And then, of course, you can't ignore all the news going on lately with cyber threats and the data privacy regulations, GDPR, HIPAA, those sorts of things. It's hard to manage. And so, we've found 84% of organizations out there have experienced an identity-related breach. And that's where SailPoint comes in, right? We try to help you to avoid that sort of stuff. You may use a single sign-on provider for your company. We're not that, we don't do that. Single sign-on kind of gets you in the front door. What we do is we give you access to the right rooms within the house, right? And make sure that you can only do what you're supposed to. And how do we build this? Well, we have a AI and machine learning foundation that we build on. I love that. That's what I do with the data intelligence organization. So I live and breathe this stuff. But like I said, what we want to try to do is make sure you have the right size access at the right time so that you're not stuck waiting on help desk to get you a new account to do your job. Nobody wants that. So let me walk you through how SailPoint started with Snowflake and kind of the journey that we've taken. It's been a fun, wild ride. About 6 years ago, when we were kind of getting into the data engineering, data processing world, we started with Apache Flink, and we were writing streaming pipelines that were doing ETL. Very powerful, but kind of hard to do. You write Java code or SCALA code, you have to deploy it out there, you got to manage a big Flink cluster to have all these things running. A few years later, the tide kind of turned and you start hearing about this new trend called ELT. So instead of the extract, transform, load, you're extracting, loading into your data lakehouse, and then transforming within there. And so we transitioned all of our data pipelines to ELT built on top of Snowflake. So we're running DBT models that are transforming our data into the ways that we need it. Awesome. It saved us tons of money. It makes it way easier because pretty much everything is SQL now, which hopefully all of you know how to do, right? And people that we hire know how to do it. There's some things though you can't do in that, right? If you have very sophisticated workloads, complex business logic, things that need to horizontally scale, we couldn't do everything in Snowflake in the database, right? So we introduced Spark to do that. We're running it on AWS, their Elastic MapReduce service. It worked. It did the job. Earlier this year, and this is where we'll focus a lot today, is we got into GPU accelerated computing. And it's pretty powerful what you can do with GPUs now, growing every day. Running it on Amazon's EKS, their Kubernetes offering. We started seeing problems with our Spark jobs that we were running. They were slower than what we anticipated. We were having to throw more resources at the Spark clusters that we were running. And because of that, the cost was going up. So we went to our friends at Snowflake and said, guys, we got a problem here. Let's see what you can do to help us. And they said, hey, have you checked out Snowpark yet? We're like, no, we haven't. Let's do that, right? So they helped us to take our Spark workload, move it on to Snowpark, and through that, we saved a lot of time, a lot of money, and a lot of complexity of having to manage our EMR environment. It was awesome, right? It was so good that we were like, this is great. Using a managed service to do this in a cheaper way, in a faster way, we love it. What else do you guys have for us? They said, well, let me tell you. Here in a few months, we're going to be talking about Snowpark Container Services. Do you have any Kubernetes workloads? Why, yes, we do. We have some. And so, we worked with Snowflake to get a private preview of that, and took our GPU workloads and put it onto Snowpark Container Services. And it's amazing, the simplicity of it. Y'all are gonna love it. I love it. It's cool. We'll talk about it more. But let's talk about a use case that we're trying to solve here. With identity security, really, relationships within the organization are very powerful to do the things that we do. All right, show of hands, does anybody know who this is? Raise your hand. A lot of hands, all right. I didn't realize this was a lunch session. I probably wouldn't have put bacon on the screen, so I apologize for that. But the reason I've got Kevin Bacon up here, if you guys, y'all may or may not have heard of this game called 6 Degrees of Kevin Bacon, right? It's based on this principle called 6 degrees of separation, which means that if you take me and you take any of the other 8 billion people in the world, then through somebody that I know, and somebody that they know, and somebody that they know, within 6 hops, I'm connected to them, right? The Pope, the Dalai Lama, whoever, right? Is this true? I don't know. I haven't ever tested my connections to Dalai Lama yet, but it might be. Fun story though, I went to high school, my best friend Brad, went to high school with Brad. After high school, he went into sound production, post-production for TV and movies, and got trained in that. Went to Hollywood, and I guess, I don't know how many years ago now, 6 or 7, 8 years, he got chosen as kind of the lead sound guy for a little show called Stranger Things on Netflix. He's won some Oscars for that, and through that process, he got to know the actors that worked on the series. Winona Ryder, Millie Bobby Brown, David Harbour. And so I am like 2 degrees away from famous. And if I go visit Brad, I may even be like 1 degree away from famous. So, but yeah, pretty cool. But with Kevin Bacon, right, the idea is that he's such a prolific actor. He's been in tons of movies with tons of different actors. And the idea is that you can pick Kevin Bacon and any other actor, and through the films that they've starred in together, you can get, within six hops, you can get from Kevin Bacon to any Hollywood actor. And so, for example, Martin Short, right? He was in The Three Amigos. He played Ned Niederlander and was in that with Steve Martin. He's also in Father of the Bride with Steve Martin, and maybe some other stuff, they're good buddies. And then Steve Martin was in Planes, Trains, and Automobiles with Kevin Bacon. You may not remember Kevin Bacon in that, but he played a pivotal role. He was the guy who stole Steve Martin's cab at the very beginning of the movie, which led to like the giant adventure that he ended up going on with John Candy. So anyway, all that to say, like, relationships matter. And how do they matter in identity security? This is where we get like less Hollywoody and more nerdy. So let me explain a little bit here. This is what we call our identity graph. And each of the nodes in this graph are a person, an identity in your organization. They're connected to other people through the edges in the graph. And the way that we connect them for the graph that we use primarily is through how similar are they with respect to their access, of what they can do, right? Bob, Joe, Susie, they've all got pretty strong connections between them. They're all engineers. They need GitHub. They can access the same repositories. They have the same Snowflake roles. They're similar, right? But Tammy and Joe are not really similar, right? Tammy does not need to be getting into GitHub. There's intellectual property in there. She shouldn't be able to get in there. Joe shouldn't be able to go and create a purchase order or pay a vendor, right? And so the access that they have is quite dissimilar. What do we do with this? We take it and we run community detection on it. And community detection is an area of graph studies, graph algorithms. There's a whole bunch of them, but the whole idea is, given a graph that's got connections with weights and associations on it, can I find communities within that graph? And you can see here, our community detection algorithm found two communities, the set of engineers and the set of finance people. These are what we call peer groups within SailPoint lingo. But we're using an unsupervised machine learning algorithm called LOUVAIN to do that. And I'm not going to get into the details of it. There's papers written on it. It's pretty cool and it works well. Go read more if you're interested. So, how does this matter for identity security? It's really useful, it turns out, right? SailPoint has something called access requests. You log into SailPoint, you have a request center. You can request access to a new Snowflake role, for example. Our users sometimes have a hard time finding what they should request. So kind of like when you log into Amazon and people say, people like you tend to buy this, kitty litter box or whatever, right? We do the same, but for access, and we're able to do that through the peer group that you're in. Approvals, once you've requested access, usually somebody's got to approve that. It's your manager, it's somebody who owns that application that you're trying to access, and often they don't have the context to make a good decision on that, right? They're like, I don't know, should I approve, should I not approve? By using peer grouping and other factors, we're able to kind of give them a thumbs up or thumbs down and say, this looks like it's something that Kelly should have, or, why the heck is Kelly needing access to create purchase orders, right? No, deny that request. Role discovery, another really interesting one and important in identity management. You guys probably know role-based access control. The idea is that instead of going and giving users individual pieces of access, you group those accesses together into roles, right? So your engineering role might have GitHub and Snowflake and all the things that you need. And so you just give the person that role and they can do all that they need. It's a hard problem for our customers because they have to go in, previously they've had to go in and manually figure out, what should my role model look like? How should I break up my users? What access should they get? Challenging, right? And so we use LOUVAIN and community detection in our role discovery process, where you can click a button and we say, these look like good roles for your organization. You should think about implementing these. And then one of my favorites is outliers. Outliers are basically the weirdos in your organization. I love weirdos. I love all kinds of people. I've got tons of friends of different, that are all different. In identity security, you do not want that. You want kind of like homogeneous type patterns of access, because when you go outside of that, you start to introduce risk into your organization, right? You don't want your snowflakes. And so with outlier detection, we use peer groups to say, hey, if you don't have any peers, somebody needs to look at this, right? Maybe you're really special and that's cool. Maybe it's not, right? Maybe I have too much access in the finance system and that needs to be removed to make me closer to people who should be my peers. So we've struggled with this, though, at SailPoint, implementing LOUVAIN. And has anybody here, how many of you guys are data engineers, coders? Okay, good. Has anybody ever used the programming language R before? All right. So unfortunately, first implementation, we chose R as our implementation for LOUVAIN. Running R in production, I would never advocate it at all. If you take anything away from this session, that's what I want you to take. No, that's not the one thing. There's a lot of other good stuff here, but don't do it. It had problems. It didn't scale. It was slow. We had to throw huge compute at it to run and make it work. And it wouldn't handle our largest customers. You know, we'd get these integer overflows, which is awful, right? And so what we did was we were able to replace it with a GPU accelerated version of that algorithm using a library called Rapids AI. If any of you guys are Python developers, check into it. It's really cool. You get like data frames that are GPU enabled and like a lot of different algorithms. They have a LOUVAIN implementation. So when we implemented it at first, earlier this year, it's running in EKS. We have data, our graph data is in Snowflake over here. We would run a query, copy that data into S3. On EKS, we'd launch a job, a pod that runs, reads that S3 data, does the LOUVAIN magic, writes results back out to S3, copies them back over into Snowflake, right? A lot of cost involved there, just from the amount of data that we're transferring, because you know, that graph we looked at had 5 people in it. We've got customers with hundreds of thousands of identities with billions of edges in them. And that's like slow, and it costs just to transfer that data, right? And it's complex. We use Airflow to orchestrate our data processing flows. And you can see here, this is what our Airflow DAG looked like prior to using Snowpark Container Services. We had a couple of tasks that would copy data out of Snowflake onto S3, figure out what size of GPU we needed, because some of these things with these big graphs, you have to have a large GPU, like 64, 96 gigabytes of GPU memory. It's got to load the whole graph in there, and so we are running some of these on multi-GPU systems that have like 4 GPU processors on them. Figure out what size to run on, actually do the LOUVAIN stuff here. This is a Python code running, copy the data back out into S3, and then copy it into Snowflake. You can see there's a lot of moving pieces there, and slowness and cost from copying the data between places. This is what that DAG ended up looking like after we moved to Snowpark Container Services. So we have one task to rule them all now. We had 10 tasks, I counted them. We had 10 tasks in that previous DAG. We were able to consolidate them all down into a single task to do everything we needed to do. But like the important part to note is that previously all those tasks were running in Amazon, in EKS, their Kubernetes service, right? This is all running within Snowflake. So Snowpark Container Services is running a container, accessing data that's in the Snowflake database. The data stays resident, and it's right next to the compute. And so it's fast, the data never has to leave, you don't have to worry about governance of moving it between environments. It's awesome. And here's where we get to the fun part, actually showing y'all what this looks like. So let me show you a little bit about Snowpark Container Services and some of the pieces that enable us to do what we need to. First of all, there are compute pools. A compute pool is a set of nodes, set of computers that you run your workloads on, right? So I defined one called LOUVAIN Compute Pool. Right now, it's just got a single node in it. You can make it as small or as big as you want. With each compute pool, you choose what instance family you want. And so there's 2 sets of instance families. You either have your standard, which are CPU only, Or you have the GPU classes. This is a fairly small one, a GPU 3. It's got 16 gigs of GPU memory on it. They go up to GPU 7, I believe, which has 96 gigs, which we were able to run like one of our really, really big graphs on, multi-GPU distributed on those. It was pretty fun, cool to see. You can set up auto resume and idle, and so when you start your compute pool, or when you create a compute pool, it's not started by default. When you put a job, when you submit a job to the compute pool, it will automatically start the compute pool for you to run that job. And so you're not paying for that compute pool time if it's not being used. You can also set auto suspend. So when your job's done, if you want to set it to 60 seconds, to 5 minutes, whatever, then those compute resources go back down. So it'll scale up and scale down automatically for you. And Muzz was telling me that there's something coming out and upcoming in the roadmap for Snowpark Container Services called Free Compute. I don't know if that's still the name that you guys are calling it, but essentially the idea is that you have a warm pool of resources. So even if your compute pool has nothing running on it, then when you submit a job, it's almost instantaneous to run that, which is pretty cool because right now it's not there yet. When I start a compute pool, it takes a minute for it to get up and running. But if we could have it scale up and down like instantaneously, set auto resume or set our suspend seconds to something really low, then we're not paying for the resources that we're not using, and it's always there. The next piece that's important to know about are image registries. And if you've used Docker before, you're well familiar with an image registry. It's a way to build a Docker image and put that image somewhere so that you can run your container, right? Snowflake introduced their own image repositories. You can use a simple command to create an image repository. I created one called LOUVAIN. Here's the URL for it, and then when I build my GPU container, I just do a Docker push to make it available within the Snowflake cloud. And then the last thing to know about here is job specifications. Job specifications tell, when you want to run a job, it tells, how do I want to run this container? You take these, they're YAML files, you put them in a stage, and here is what one of these things looks like. Pretty simple, kind of similar to like a Kubernetes pod spec. It's got a container defined named LOUVAIN Snowflake Summit. That image that we push to the image repository is listed here. And then you give it arguments, what do you want to run? This is a Python program. We're running our LOUVAIN algorithm. And the results are going to be written into this table called mapped LOUVAIN. All right, are you guys excited? Are y'all ready to see it happening? All right, let's do this. I went to a cool magic show last night. It was hilarious, and there's a bunch of like data science, data engineer nerds there, and like they were trying to call out the magician on like everything. Like, no, you've got that card behind your pocket. No, let me see what. It was fun, but to prove to you that I'm not pulling one over on you, I'm gonna delete from our result table first. Nothing in there. Nothing in the table anymore. The Jacquard data, this is our graph data. And let me show you what it looks like. There's about 3,800 edges in this data set. Pretty small graph compared to like what we run on most of our customers. Each of these edges has an ID for one of our identities, a unique identifier to another person. This is your relationship. And then how strongly are they connected through that Jacquard similarity that we talked about. So about 3,800 of those edges, about exactly 92 identities in there. And what this looks like is this. This is our identity graph in action. A little bigger than the one we were looking at earlier. Kind of a big ball of spaghetti, hard to make sense of. Each of these dots in here is an identity in your organization. Each of those lines going to other people are the Jacquard similarities, right? So let's do it, let's run this thing. To run it, really easy, a simple command, execute service. 2 words, execute service. You just give it a compute pool, what type of instance do I want to run this on, and you give it the job specification. For this one, I'm just using our small compute pool. For our larger customers, we would use a compute pool that had that GPU 7 in it to run on the multi-GPUs that could handle the big billion edge data sets that we deal with. So you run that, you get an ID back for your job. At this point, that Docker image has been pulled onto a node in that compute pool. The pod has been started using the specification here, and it ran. You can see, you can use the system function to get the job status. This one's done. It finished very quickly. If you want to see what happened, you can look at the logs for your container. This has all the logs from your container so that you can monitor and see what happened. And so you can see here what we're doing is pulling out those Jacquard edges, pulling our graph data from Snowflake. Here we're putting it into a GPU-enabled data frame. So it's living in the GPU memory at this point. And then we run LOUVAIN. And we actually run it a number of times to figure out what gives us the best communities possible, what makes the best peer groups. And eventually we end up with our results. And so each of these is an identity ID, and this is the peer group that this identity falls within. So we see this guy and this guy are both in peer group number 4. So these two are peers. And then finally, that data, the peer group data, gets copied back into Snowflake. So let's look at what the results look like. There's the peer groups. This was able to find 7 different peer groups, ranging in size from fairly large. 4 of them are kind of large. 3 of them are pretty small. And so that big messy ball of spaghetti that we were just looking at, it's still a big messy ball of spaghetti, but it's colorful spaghetti now. You can see who is connected to whom through the colors on here. Those indicate the peer groups. So we've got kind of 4 dominant peer groups, the blue, the red, the orange, the green. We've got some smaller peer groups as well. There's one tiny one. Where'd that guy go? Little 2-person peer group, little sad guys sitting out there by themselves, or maybe they're an elite team, I don't know, but those are the peer groups that we created from that. So that's the demo, that's the code that I've got to show there. Let's talk about what benefits came from this. Let me just recap some of the stuff that we went through there. For one, we were able to go to a fully managed Kubernetes service, which is huge for me. We have a DevOps team at SailPoint dedicated to managing the EKS environment. And to get them to get GPU support and node groups that supported GPUs in there it took some time, I'll say that. Painful, right? Very painful. We don't have to do that anymore. All you do is run that create compute pool command, tell it you want a GPU, and you've got it. So you guys saw that Airflow DAG went down from 10 steps down to 1 step. So the development was simplified greatly by keeping all that logic together. We were able to do everything we needed in 1 step. And then finally, we never left the Snowflake cloud. As opposed to having EKS and Snowflake and copying data back and forth between them, We didn't have to do that anymore. All the data stayed resident. So it was a lot faster and saved money on these huge graphs so that we didn't have to pull them across the wire between our different environments. All great. We love it. Like, if you need an advocate for Snowflake Container Services, come and talk to me. I will talk to you for a long time about it because it was so easy to use. Snowflake just keeps helping us out over and over again. I'm happy to talk to you about it. But what are we going to do next, right? We have a ton of stuff running in EKS right now, and our DevOps team has to manage that. Anytime we need something new, we got to put in a request. They've got to go take care of getting it to do what we want it to do. It's painful, so we're going to take a look at how many workloads do we have that would make sense to start running in Snowpark Container Services instead of EKS. The next thing that we're going to do is for these distributed computing, Spark, sophisticated workloads, we saw that, like I mentioned, we saw huge benefits going from EMR to Snowpark. And so we're going to keep doing that as we add more and more complex processing in. That's these distributed computing. We're going to keep looking towards Snowpark for our Spark-like workflows or workloads that we have. And the last thing that we're going to do is keep partnering closely with Snowflake. I don't know how close you guys are to your Snowflake reps. Ours are awesome. Aaron, John, Muzz, Puneet, these guys have worked with us very closely to move from Spark to Snowpark, to move from EKS to Snowpark Container Services. And they're doing it not because they want more of our money. I mean, they do, of course, but they're doing it because they want us to be successful. And it's actually saving us money by spending it on Snowflake instead of AWS. So it works out. But if you guys aren't friends with your AWS partners yet, please go talk to them. They are a wealth of resources, and they keep me informed all the time of like new stuff that's coming up that will help SailPoint in our journey. All right, and with that, I'm going to hand it over to Muzz. That's all I have. He's going to talk a little bit about what's coming up from the Snowflake perspective.
Wow, that's a very hard act to follow. So I'm not going to follow. I think Kelly spoke everything I wanted to speak about. But as you know, we're in private preview. We're getting started. You saw how SailPoint, the first customer to start pushing the limits of GPU, and how incredible Kelly and his team has been. It's exactly what our vision was, to unlock these workloads. It makes us so happy to see that. But we're going to start expanding to the clouds. We're going to start doing what Kelly was talking about, the warm pool. So it's instant on experience, container coming up. We're going to start fully supporting distributed trainings. So there's a lot of exciting stuff happening. Thank you, everyone.